Can we hear? Yes, we can hear. Let me just bring in an image. There we go. All right. And my own daughter sent me a sideways image. My own daughter. Et tu, Brute. Where are we going with this? Rotate. Come on. All right. This is what we're working on. That's not level, but we're going to deal with it. Okay. So we've got solve for x. Log base 3 of x plus 1 is equal to log of 5. Now, the reason why this is confusing is, first of all, because they break from this function notation here, and you're just not used to dealing with log and thinking of it as a function. The other thing is that because there's letters here, you resist the idea that that is a constant number. But you can just type this into your calculator. If you just type log of 5 into your calculator, it's going to be approximately some number. It's just going to be a gross decimal. It doesn't really matter what it is. It's a constant. That's the thing that's important. The other thing is that the inverse of this function, we'll get to that in a second, is the exponential function, right? Here it's actually base 3, not e. So this is the inverse function. And you're thinking to yourself, like, that's a function? Well, it's like the exponential function. If I write it like this, some people prefer this notation. Now you can see it's a function. It's in function notation. That looks beautiful. And I don't know if I've seen this done anywhere, but you could write base 3 there, so that it's clear this is base 3. This function is the inverse of log base 3. Okay? So let's say if this is f of x, we'll define that to be f of x with our triple equals there, then this would be f inverse of x. And vice versa. They're inverses of each other. So it's much clearer in this situation here. And let's remember the essential property of inverse functions. If we have a function and we compose it with its own inverse, we get whatever's inside the parentheses. That's the argument of the function. We get that out. Okay, and vice versa. And actually, when you rewrite the same thing in a different notation, we would say f of f inverse of x. So f of f inverse of x. F of f inverse of x. Same thing. These mean the exact same thing. Now, we can also do it in the opposite order here. We could do f inverse on the outside. We'll compose f of x with that. And that would be denoted this way if we're using this kind of like composition operator symbol here. So this is a chain of equality. That's equal to that, that's equal to that. It's really important to recognize that. Okay, so that's what we're going to use to solve this problem. Okay, so this is what you'll write down when you solve this. Let me use a less spicy color. Go black. All right, so start off by writing the equation. If you're being a super extra cool guy, you would do 3 to the log base 3 of x plus 1 equals 3 to the log of 5. And then we will, so this cancels here. You can write that x if you want to or don't. This becomes x plus 1, which is equal to 3 to the log of 5. And then subtract 1 from both sides. Okay, and there it is. This is a number. You can plug it here. I'll put this in my calculator. 3 to the log of 5 minus 1. This is approximately squiggly equals approximately 4.8. This is like 5999, so I'm going to do 86. There we have it. So the main issue is this is a constant number. We can't lose sight of that. Log of 5 is a constant number. Okay. Then once you move past that, we have to remember the inverse of this is the exponential function.
out of that argument. Okay.